Hello, I welcome you on to this another interesting screencast. The problem reads, determine the power input for a motor necessary to lift a 300 pounds at a constant rate of 5 feet per second. The efficiency of the motor is 0.65. Okay. So this problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. So let's draw what we have. So let's imagine it's a box. Let's imagine it's a box. And the weight of this particular box, we've been told, is, of course, yes, this. So let's say it has weight equal to 300 pounds. And then we are lifting it at a constant rate. Okay, we are lifting it at a constant rate. All right, so let's call this our T. And since the speed is constant, we expect AY to be equal to 0. Okay, right. So there we go. We have something like so. So let's say this is our X and this is our Y. So let's write down the equation. So we'll say summation of forces in the Y direction equal to MAY. But we know that AY is equal to 0 because V is constant. And therefore we are going to have T, okay, minus W equal to 0. And therefore our T will just be equal to W, which is just equal to 300 pounds, right? Okay, all right, so we have our T. Of course, now let's get back to the question here. We have been asked to find the power input for the motor. All right, so for us to find the power input, we need to find the power output. Okay, so let's do so. So our power output is just going to be equal to the force, which in our case is the Ty, okay, times Vy, okay, because we know to say power itself is just equal to the work, okay, the rate of doing work, which is just equal to the force vector dr, okay, with respect to time, and this is just equal to force dot V. All right, so our Ty, we said, is just equal to 300 pounds, and our Vy is just equal to 5 feet per second. And therefore, our power output is just going to be equal to Ty is 300 times 5, and this we just get a 1500 feet pound per second. Okay, Alright, so once we have this, then we'll need to use the equation for efficiency. Efficiency is just the ratio of the power output to the power output. So this was supposed to be power output, right? I didn't write it properly. So this is power output. So this is power output. Alright. So this one here is power output, okay, to power input. Alright. So the power input is just going to be equal to the power output divided by the efficiency. Right, the efficiency. So this just becomes equal to, we found that our power output is 1500, right, and divided by the efficiency, which is just equal to, divided by the efficiency, which is 0.65. Okay, and therefore this we just get 1500 divided by 0.65. So this we get a 2307.69 feet pound per second. Right. So we have determined the power input, and I guess this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.